Hi everyone, so today I'm going to be talking about sea star wasting disease and environmental change in Sitka, Alaska. The first thing I want to go over is just a little bit of a roadmap, talking about everything I'm going to highlight in the presentation. So first I'm going to start off with my research question, then some background about why I chose the topic. Next we're going to delve right into my topic, which is sea star wasting disease, then look at my study area, then go over some of the methods I took to answer my research question, then go into my findings and future directions. So to start off with my research question, I feel like this little graphic simplifies it, exactly what I'm trying to find out without overcomplicating things too much. So first I have sea star wasting disease, and then I have the environmental changes taking place in my subject area. And I'm just looking for any association between the two, whether that be causes or exacerbating factors. So then to go into some background, why I chose this topic and why in Sitka was because I was actually in Sitka a couple months ago. I did the field course, which 10 out of 10 would definitely recommend. But yeah, so this is me in Alaska. While I was there, I saw lots of sea stars and lots of sea star wasting. It was a really surreal experience to see all of this taking place right in front of me. Because of that, I became really passionate about the topic, and that's why I decided to make it the topic of my final presentation. So now moving into what sea star wasting disease is. It was first documented in North America in the 1970s, so it's been around for quite some time. It's evolved today to describe a general set of symptoms experienced by various sea star species. What we know so far is that it progresses really quickly. It's often fatal, and unfortunately there's no definitive cause as of yet. The reason it's kind of relevant today is because we are presently experiencing the largest wasting event in recorded history. While there have been wasting events in the past, none of them have been this severe or having taken place on this broad of a scale or affected this many species. The other thing I want to note on this slide is just the two species in the pictures. One is going to be the sunflower sea star, which is this guy right here, and the other is the Ochre Star. Those are the species that are very predominant in Sitka and the ones I'm going to be talking about a little bit throughout the presentation. So next I want to just kind of talk about the signs and symptoms of sea star wasting. The first sign is going to be ray twisting, which you'll see right here. This is going to be normal ray twisting, so pretty standard. Then this is going to be the abnormal ray twisting, which is usually the first sign you'll see before the rest of the symptoms kind of unfold. Next is going to be lesion formation, which these lesions right here will form. They can be singular, there can be several. These are just some singular lesions on some ochre stars. Next is going to be tissue decay. So here you can see where the lesion has kind of evolved to just into decay of the lower ray or the lower arm. This is a more advanced kind of stage of the decay, but does show what happens following the lesions. Following the tissue decay is fragmentation. Here we can see where a lesion led to the partial fragmentation of this ray. Here is an example of complete fragmentation of two rays. A lot of the times, once this fragmentation occurs at such a severe level, mortality usually follows, and that's the next stage right there. Sometimes they can recover though. This picture is an example of a little star that did end up recovering. So you can kind of see right here, this is where the ray fragmented, and this is some regrowth. There's a little bit of scabbing if sea stars could scab, or if they did scab, that's what this is at the end of these little rays. So growth and recovery is possible, but not in all cases. This video I'm about to show you guys is an example of a star that didn't end up recovering. Just for some context, this is going to be the central disk, so the main portion of the star, and all of these little things are going to be the rays that have all completely fragmented off of the star. And unfortunately at this stage recovery is just not possible. This is a video I actually took in Sitka at one of the aquariums. And once this happens, you know, there's really no recovering. And after I took this video, the head aquarist actually ended up just humanely euthanizing the star, unfortunately. Here's just some additional examples. So this is going to be a regular sunflower star. This is a star that has, or a sunflower star that has experienced wasting. So you can see the fragmentation here, up here as well. And then in the Ochre Stars, this is going to be normal stars, and here's some wasting stars. You can see the fragmentation, the loss of shape, some lesions up there as well. So now I'm just going to talk about my subject area a little bit. This is a map generally of where Sitka is. So right here is this area. This is going to be Baranof Island down here, which is where Sitka is located, and Sitka is actually here where this orange, or this cluster of orange little pinpoints is. And here's a zoomed image of that portion of the island. This is going to be Sitka itself. You can see all the development there. This is actually the airport. And again, all these little orange pinpoints, that's actually going to be where wasting has been observed and documented. One thing to note, though, is that this doesn't mean these are all of the places where wasting has occurred. It's either just the places that are accessible for people to go and make these observations, or they're just places where people actually documented. So there's definitely many more areas where the wasting is occurring. They just either aren't accessible to people or just haven't been documented to this database. But now moving forward to some of the methods I used to answer my research question. While I was in Sitka, I was at the Sitka Sound Science Center quite a bit. I talked to the head aquarist there, as well as a lot of other individuals that are just super well versed in wasting and wasting in that area in particular. So I got a lot of data and information from them directly. I also contacted the Marine Network, which is the multi-agency Rocky Intertidal Network based out of UC Santa Cruz. They are the ones who made the all of the maps you've seen thus far in the presentation. They have a really great database that kind of maps and tracks wasting. So I emailed back and forth with them, got a lot of really great information, and then I also just got a lot of information from the internet using publicly available data. After collecting all of that data, I kind of made my own observations and analysis by comparing the data I received to environmental data I looked up as well. To make my conclusions. So moving on to looking at what environmental changes I'm kind of looking at or focusing on. The first two are relatively the same. They're essentially climate change or temperature fluctuations. One element I'm going to show you guys is monthly air temperature fluctuations from 1990 to 2009. The next is going to be annual air temperature changes or fluctuations that compares historical data and future data. The third element is going to be sea surface temperature change, which is very relevant considering that the sea stars are actually in the water and not on land. The last thing is just going to be land cover changes from 2009 to the present. So first we have this image that showcases the monthly mean air temperature from 1990 to 2009. The main thing I want you guys to focus on is right here. So aside from the months of June and July, Sitka is going to be red, basically, meaning very high temperatures throughout the year and just abnormally high temperatures compared to the rest of the state. So that's just basically indicative that the temperatures are very, very high there compared to previous years and also compared to the rest of the state. So I'll let that kind of finish up. And then the next image is just an image. It shows absolute annual change in temperature for the state, and it combines data from 1975 to 2005 with predictive data, or data that is predicted to happen in the future between the years 2071 through 2090. So that is combined to just show change occurring temperature-wise throughout the entire state, where the dark red is a lot of change and then the lighter colors are less change. This image I thought is relevant because while it doesn't show as much change occurring in the Sitka area, which is going to be right here, compared to the rest of the state, it is showing significant change, which is important because it is indicative of a warming temperature or warming climate in the area. So next I have this little video that's showing annual sea surface temperature. So this data is from 2009 to the present, so 2021. The lighter color blue is going to be warmer water, while the darker color is the colder water. So I'm going to press play here. And as you can see, there's a gradual shift into warmer waters throughout the years. I'll stop it at the end and then go back to the beginning so you can see it kind of compare it a little bit better. But I'll just let that play out for now. Okay. So as you can see, the water within the Sitka region is significantly warmer than it was in 2008, and this is the image from 2008, just for a little bit of comparison. So that just basically illustrates that the water temperature is warming as well. And then the last category is going to be land cover change or changes in vegetation. This is the Sitka area. I moved the star up a little bit just so you could see the change occurring along the coastline. But as you can see where the coastline is, that's where the most change is occurring. So that's going to be the color red. And if you remember on one of the previous maps where all the little orange pinpoints were, they were along the coastlines. So these align pretty well as far as where the wasting is occurring and where this land cover change is occurring as well. So based on those images and based on the just information on sea star wasting disease, what I have concluded from my research is that if warmer climate is not the underlying cause of the wasting, then it is definitely most likely going to be an exacerbating factor for the disease. Specifically, the warming climate and warming temperatures may increase stress for the sea stars, making them more vulnerable or just increasing vulnerability in general to the disease. Because of these findings, I would suggest that research be done going into the severity of symptoms and how that correlates with warming waters and warmer temperatures, as well as the progression of symptoms. So maybe in warmer climates, the symptoms progress more rapidly. I would also suggest researching whether higher mortality rates are experienced in areas with warmer waters or warmer temperatures. And then moving forward, just some of the things that I would also suggest and some of the things that I believe would be critical to, finding that distinct underlying cause of the wasting is just research. Because without identifying the exact underlying cause of the disease, there's no way to come to a consensus in terms of how to actually combat it. And research is the best way to just find that cause. I think some really important things to look into would be specific species resistance. So looking at species that may be more or less resistant to the disease. Also maybe looking at regional factors affecting disease prevalence. So in one of the images I showed like the land cover change along the coastline, and the coastline is very close to the sea star habitat. So maybe how the changes and how those factors may affect the disease prevalence. And then additionally, just continued GIS mapping and tracking to look at where the disease is located and severity and stuff like that. Pretty much all the maps I've showed you guys have to do or were taken with some sort of GIS database or satellite. And that has allowed me to make a presentation like this. And I think it would allow others in the future to continue expanding upon the research database and just make further conclusions and findings and suggestions about how to combat the disease. And so now I just have my citations page. That's pretty much it. Thank you guys for listening. I hope you guys learned a little bit. And if you guys have any questions, feel free to ask on the discussion board. Thanks.